talk about the characteristics and differences in the proofs and the use of two rules. Okay. The similarities are that both values are approximate and estimated, both rules approximate the function by a vertical segment, and to derive the y values, substitution of the x values to the equation by the two methods are required. The difference from trapezoidal and Simpsons are shown here. Trapezoidal, they have number of strips must be at least 1, and that even or odd number of strips can be used. For Simpsons rule, n must be at least 2, and only even number of strips can be used. Okay, the advantages of trapezoidal and Simpsons rule. For trapezoidal, minimum of strips required is 1, and it is also straightforward. For Simpsons rule, it is more accurate. The disadvantages of trapezoidal rule is that it is not as accurate as Simpsons rule, and for Simpsons rule, in applications such as experimental or simulated data, it cannot be used, and that is only applicable to even number of strips only.
I'm trying to derive the formula for trapezoidal rules using this graph. Okay, let n be the number of strips and h be the width of the strips, which is equals to b minus a over n. And each strip can be equated to the area of a trapezium, which is this formula. And to get the area under the curve, we use the integration of fx dx, and we remove the common factor h over 2 to derive this formula, which is the trapezoidal rule. Now I'm trying to prove to you the Simpsons rule. From this graph, you can find out how the Simpsons rule gets out. Okay, yo is this line over here, and you can sum in the value of x to be x minus h into this equation, and you derive it to be this one. And so on, you will get into this equation, which is you sub x to be 0, and you will get c. For this one, y2, you will sub x to be h, and you will get this value. To integrate this value, you can do it through the integration method, and you will get these end results. This one. Okay, so this result y0 plus 4y1 plus y2 can be changed to 2ah squared plus 6c through these three derivations here. From the derivation you derived earlier on, you can add up all them together to get this final equation, which is the Simpson formula. And this one is only applicable to even number of strips only. That's all. Yeah. Any other alternative? Yes, we can get it through the Gaussian quadrature and square rectangular rule.